Good evening, student. Today I will discuss about some basic problems of temperature coefficient alpha. Okay, so already I have discussed about the temperature coefficient alpha, whose value becomes positive for conductor. Why? Whose value becomes positive for conductor? Because whenever we increase the temperature of that material, so the resistance as well as the resistivity becomes increases. Due to increase of resistance or resistivity, that alpha becomes positive by using given formula, that is R equal to R0 1 plus alpha T. Okay, so this is the given formula. By using that formula we can derive some problems. Okay, so this is my first problem is the resistance of a heating element at room temperature 27 degrees Celsius is 100 ohm. At what temperature its resistance will be 117 ohm. Already the value is given, that is the temperature coefficient alpha, which is equal to 1.7 into 10 to the power minus 4 degrees centigrade inverse. Okay, so here in that case the resistance of heating element at room temperature 27 degrees Celsius is 100 ohm. That means answer given at T equal to 27 degree centigrade, initial resistance which is equal to 100 ohm. At what temperature, that means T equal to what? For what temperature, that means T equal to quotient, at that time the resistance, that is final resistance of that heating element, which is equal to 117 ohm. And also in that question alpha is given, that is alpha equal to 1.7 into 10 to the power minus 4 degrees centigrade inverse. So how to calculate that type of value? We know the formula, that is R final, which is equal to initial resistance into 1 plus temperature coefficient alpha into change in temperature. So this is the formula of the final resistance. When we put all this value, then we can define the value of temperature. Okay, so here RF equal to 117 into R0 means what? That is 100 plus 1 plus 1.7 into 10 to the power minus 4 into del T means T2 minus T1. So here we write 117 divided by 100 minus 1, which is equal to, that 100 represent in the lower value of left side in denominator, which is equal to 1 plus 1.7 into 10 to the power minus 4 T2 minus 100. Clear below? Okay, so in that case we can write 117 by 100, that 1 which is in left side, that is minus 1, which is equal to 1.7 into 10 to the power minus 4 T2 minus 100. sorry, T2 is 27, T1 is 27, sorry, by mistakenly, right, that is 27 degrees Celsius. Okay, so in that case 117 minus 100 divided by 100 into that value, that is 1.7 into 10 to the power minus 4 is here, which is equal to T2 minus 27 degree. Clear? Here. That means 17 divided by 17 to power कहते 10 to power minus 3, because 17 by 10, so 10, that 0 cancel out, so 10 into 17 into 10 to power, that is 17 power 10 to power minus 3, that is my plus 27 degree, which is equal to T is 0. That means 17, okay, and that is about, that is 17 cancel out here. In that case, that is 10 to power 3 plus 27 degree equal to T. So that implies 10 to power 1000 plus 27 equal to T2. That means the final temperature, its resistance will be 117. That final temperature is given by 1027 degrees centigrade. Okay, 1027 degrees centigrades. So at that final temperature 1027 degrees centigrade, the resistance, that is the final resistance, is given by 117 ohm. Please note it. So this is my second question, which gives the resistance of platinum wire is 5 ohm at ice point. The resistance of platinum wire is 5 ohm. गोटे platinum wire नबा ता resistance केते 5 ohm. केते बड़े गोटे ice point रे. Ice point माने केते temperature 0 degree Celsius. And 5.5 ohm at steam point. Steam in बाष्प होउछ. जल केतोल बाष्प होबो 100 degree Celsius रे. That means 100 degree Celsius रे platinum wire रो resistance केते 5.5 ohm. Find the temperature at which the resistance of the wire is 5.8 ohm. कौन पचारची टेम्परेचर कैलकुलेट करो केते बेले जेते बेले से प्लैटिनम वायर रो रेजिस्टेंस केते हितिबो 5.8 ohm हितिबो. Again I repeat that question. The resistance of platinum wire is 5 ohm at ice point and 5.5 ohm at steam point. Find the temperature at which the resistance of the wire is 5.8 ohm. From above question, here we given that means at temperature T1, that is 0 degrees Celsius, the resistance R is given by 5.5 ohm. Sorry, 5 ohm. That is R1. At steam point, at steam, that is at steam T2 equal to 100 degrees Celsius, so R2 is given by 5.5 ohm. At what temperature, that is T3, is becomes question tag. So that resistance R3 is given by 5.8 ohm. How to calculate? As we know that the relation between temperature coefficient and resistance, that means R equal to R0 into 1 plus alpha delta. Okay, by using that formula we can derive that value. Now in first two case, in first and second case, compare first and second case, compare first and second case. Here at 100 degrees Celsius the resistance become 5.5 ohm. At 0 degrees Celsius the resistance become 5 ohm. So we can write in first two case, that means R 100 degree which is equal R 0 degree 1 plus alpha into del T. Del T means T2 minus T1. So T2 minus T1 means T2 kete 100 minus 0. Okay? Similarly, when you compare, we compare first and third case, R final temperature T which is equal to R0, that is initial temperature 0 degree Celsius, R0 1 plus alpha, that means T minus final temperature, that is T, initial temperature kete 0 degree. Here that R100 means what? That R100 can be represented as R100 100 degree Celsius पे resistance R2 कितना था 5.5 ohm which is equal to R0 कितने 0 degree centigrade रे कितने R0, that is 5 ohm, 5 into 1 plus alpha 100 minus 0. Clear पिले? Similarly, एक केस पे जेतोले देखिबा at room temp, at resistance, at final temperature, that is RT. RT केते अछि 5.8, that is RT means at T temperature, that is 5.8, that is temperature T3 can represent 5.3. At temperature T3 the resistance which can be represented 5.8, that is 5.8, and R0 can be represented as R1, that is 5 ohm, into 1 plus alpha, that is T means T minus 0. At final temperature that becomes calculated, so T is here, 0 is here. So that is equation number 1, that is equation number 2. So dividing equation 1 by 2, dividing equation 1 by 2. So that is 5.5 by 5.8 which is equal to 5 into 1 plus alpha 100 minus 0 divided by 5 into 1 plus alpha T minus 0. So we can write that is 5.5 minus 5, that multiplied with 5, so we can eliminate from right side to left side. So 5 minus 5, like 5.8 minus 5 equal to. So here you write 5 alpha 100 divided by 5 alpha T. So alpha cancel out. So in that case we can write that it is 5 by 5.3 which is equal to 100 and 5 cancel. So 100 divided by 3. That implies T equal to 100 into 5.3 divided by 5. Clear? So we can write that is 20. So sorry, that is 5.5, 0.5 is here, sorry, that is 0.5, and that is 550.8 is here. Okay, so here in that case, what will happen, that is 5 by 8 is here. So 100 into 8 divided by 5. So 20 is 500. So that is 160 degree Celsius. For the temperature 160 degrees Celsius, at which the resistance of the wire is 5.8 ohm. Please note it. So this is the second question. Now my third question is, so let us consider two different wire of area A and length L, and the material whose resistivity is ρ1 and ρ2, and temperature coefficient alpha 1 and alpha 2. Find the relation between resistivity, that is ρ1, alpha 1, ρ2 and alpha 2, such that the resistance of the combination is independent of temperature. Let us consider two different wire. Suppose this is wire number 1 and another wire, that is wire number 2, whose area A and length L, and that wire is also area A, length L. Okay, so these are the two different wire, that's the two different wire whose area A, length L, and also whose area A, length L, whose resistivities are ρ1 and ρ2, that is ρ1, that is ρ2, and coefficient, temperature coefficient also, that is alpha 1 and alpha 2 is here. Find the relation between ρ1 alpha 1, ρ2 alpha 2. Ketebale? Such that the resistance of the combination is independent of temperature. Jetebale ki dida jaka resistance, the combination of resistance, that means combination of resistance in final temperature. At that case, both of the resistance of the two different wire is independent of temperature. केवल temperature ऊपर depend करिवे नै. एक गोटे जो आमे पढिथिले independent of temperature कोड पढिथिले alloy case रे पढिथिले. alloy case रे कोन होतला, जेतेबेले कि आमे गोटे alloy नउथिले से जगह रे जो material आमे व्यवहार करथिले like as constantan, manganese or nichrome wire, on that wire when we increase the temperature, at that case the resistance becomes unaffected, nearly unaffected. So that case will be considered in that question. Okay, so whenever two wires are connected, suppose आमे दीटा wire को connection करिबा, तार त आमे 10th class रे पढिछे, तमे एबजे पढिनो बा तमे capacitor रे पढिथिबो. Capacitors are series in connection. In case of two wire, that wires are resistances are there. So whenever we connect the two wires, and that connection behaves as a series connection. What? When two wires are connected in series, then what will happen? Then the resistance of that combination, so resistance in combination, which is equal to R1 plus R2. That is the resistance of the first wire, and this is the resistance of the second wire, that is R1 plus R2. So by changing the temperature, आमे जेतेबेले कोन करिबा, एट कोन कहछि इंडिपेंडेंट टेम्परेचर हम कोन करिया चेंज करिबा, कोन टेम्परेचर. By changing the temperature, what will happen? The resistance becomes unaffected. That means it is independent temperature. That means initial resistance etik thila, final resistance bhi setik rahibo. Therefore, resistance in final, which is equal to resistance in initial. That is the resistance combination in final. That is the resistance combination in initial. So resistance combination in final, that is the combination in final, that is the final case, that is resistance combination in initial. So as we know that the relation between resistance and temperature coefficient, we can write that is resistance in combination means what? That is final resistance RF plus R2F boli consider kore dita. It is the final resistance of first wire and this is the final resistance of the second wire, which is equal to initial resistance, that is R1, and initial resistance of the second resistor wire is R2. So RF can means what? R0 into 1 plus alpha delta, that is the final resistance of the given wire, which is given by R0 into 1 plus alpha delta plus similarly R0 into 1 plus alpha delta. Okay. So here we write that is alpha 1 and that is alpha 2 is here, because in above case alpha 1 alpha 2 is here. So we can represent the temperature coefficient in alpha 1 and alpha 2. Similarly here R1 is here, that is the initial resistance is here, that is R1, and initial resistance of second wire is R2. Okay. So in both of the cases we can write that can be represented as R0 plus R0 alpha 1 delta plus R0. R0 means what? That is R0 means that is R1, we can write. Okay. R0 of second final resistance, that is R2. Okay. So we can write that is R0 can represent R1, that is R1, that is R2 plus R2 alpha 2 delta, which is equal to R1 plus R2. So R1 R2 cancel out. So that R1 alpha 1 delta plus R2 alpha 2 delta, which is equal to 0 is here. Okay? Which is equal to 0 is here. So now we can represent that R1 in term of rho 1. So how to convert? So as we know that R1, so R1 it means R given as, we can write R is given by rho L by A. So in that way we can represent that R1 can be represented as a rho 1, length area remains same, so L A alpha 1 delta is here plus R2 is here, L by A is here, alpha 1 delta is here equal to 0. So here we write R1 rho 1 alpha 1 L by A delta, which is equal to rho 2 alpha 2 minus sign is here, L by A delta. So L by A cancel out, delta cancel out. What will happen? Rho 1 alpha 1 plus rho 2 alpha 2, which is equal to 0. So this is the relation between rho 1 alpha 1 and rho 2 alpha 2, which is equal to 0. Whenever it is independent, the resistance of the combination, the final resistance of the combination is independent of temperature. So please note it. If any doubt, then ask me. So this is overall basic problems of temperature coefficient alpha. If any doubt, then ask me. Okay. So thank you.